Hello friends, today we will see Profile 3D and Profile 3D operation will work along the edges of 3D faces. Here we will not select any face, you can directly select any contour edges of the part, right? So let's see. In Solid Profile 3D, we have already defined all the things like NCS tool, workpiece. So in Profile 3D, I'm not going to define these things again. I'm using the previous file for this operation. Just delete the Profile 3D and now I'm using Profile 3D. Same options. Okay. Here, come to this geometry and the part geometry is the curve. Select the curve. Here you can select 3D curve. These all are 3D curve. And my boundary type is open and OK. Tool side is right. If it is not OK, like I'm selecting left, OK. So tool is coming inside. Let's see the result and generate. See, it is OK. If it is not OK, just go and change the direction of this tool side. OK. Rest option are still the same. If you want to define Z depth offset, again same value you can use. In negative or positive, both direction it will work. 0. Multiple side, same option. Multiple depth, the same option. Strategy, under strategy, if you want to extend, you can also extend at the value. For merge distance, here we are not using any face, so merge will not work. If you want to smooth in Z direction, so this option will work. And click here to verify. Just say this. Hope you understand this. Thank you for watching. Have a nice day.
Today we will see one more example on Streamline, and today we will cover this example. If we have any undercut area, so how we can use Streamline to cut that kind of geometry. So we have this type of curve right now. So I'm going to use a T-cutter tool for machining this part. So first come to workpiece and define the part, and for blank I am using offset from part with 0.5 mm offset, and I need a tool and a T cutter I have already defined. If you want to check, I will show you how to check. Click here and see whether it is possible to cut undercut with this tool. Yes, right now we can cut with the help of this tool. Okay, the only one thing is there, you need to define a little bit longer tool. Now click here and I am using Streamline. Workpiece is this, and this is my finishing operation. First of all, define the geometry so that the flow curve will automatically detect. Select this. Okay, this is the cutting area. Now come to main, and here in main, streamline definition, and we will find one flow curve and second flow curve. Now the cut pattern is zigzag and step over is 10, so no problem. I am going to use the same default parameter right now and generate. Let us check the result. So this is 3 axis and it is not cutting the whole part because of tool axis and projection vector. So here I am going to add one more thing. Tool axis is Z, this is projection vector. So this time the projection of my tool path should be on this surface. For that I am using towards line, and my line is this center of this part, this Z direction. Let me check now. Right now tool is working like this. Replay this. It is starting from the bottom, but I don't want to cut from the bottom. It should start from the top. So come to main, and here in streamline one option is there, the cut direction. So I'm selecting the top arrow for defining this direction. By default first flow curve is now this one, and here if you want to increase the step over, so increase this step over. And the cut pattern I am using helical or spiral, so it will create a continuous cut on this cylindrical surface. Projection vector we will discuss in upcoming lecture. Now see this. And in 3D dynamic, now this is the helical cut pattern. So hope you understand this, how to create undercut toolpath with the help of Streamline. Thank you for watching. Have a nice day. Hello friends, in this lecture I will show you how to create a streamline between two guide curve or between these kind of shape. So first I have not defined any part or blank. I am directly using my Z direction is in positive direction, so it is okay. Now the tool is already defined. Now come to this operation, and here I am using streamline. For streamline you can directly select the surface. With the help of geometry it will automatically detect the primary curve and cross curve. So I am selecting the surfaces which I want to be cut. Okay. Okay. Now if you will see on main, it will automatically detect the flow curve and cross curve. You can see the first flow curve is this, second flow curve is this, and for guide the first guide is this, second guide is this, and direction, the direction is this one. So in this direction it will start, and I am just using 10 for initial number of cut and generate and see. It is coming outside. Let me check why. Okay, just increase this 40. Okay, and go to geometry and see the area. So this is complete face is selected, that's why it is going on this. Don't select this upper face. Now it is symmetrical and okay. This is vertical face, so it is not suitable to use streamline for this vertical. And now I want to change the direction, so click here, and from here direction I want this direction, okay, and generate. Right, if you want to see the replay, go to replay. 3D replay will not come because tool geometry workpiece is not defined. Here you can see the tool path is, the tool is colliding, it is generating the gauge with the part. Now double click here, my part is this one, and for blank I am using offset from part and 0.1, okay, and now generate this again. The tool path will automatically adjust, okay. Now it will not create any gauge. Say this. Without the geometry, without the workpiece, we cannot check the tool path. Say this, because the tool die is big, so it is not creating the tool path here, although it is touching with this vertical wall, okay. If I want to check it, click here and check the gauge with part blank IPW and okay. So this is the report, no gauge is found. So this tool path is okay, and if you will validate this, it is okay. So hope you understand this. Thank you for watching.